It's the middle of summer, no air conditioner, no electricity, no fans, and yet this room is cold. Not coolish, cold, the kind of cold that makes you stop walking and just stand there. How? There's a tunnel, just a tunnel, buried about 3 meters underground. No motor, no refrigerant, no electricity bill. The Earth itself is doing the cooling, and this system costs less to build than a single month of running central air. This isn't science fiction. This isn't a concept. This is a 2,500-year-old Persian engineering secret, and it works better than most people's ACs. They call them cannons and earth tubes. Persian engineers built underground air channels across the entire ancient world. The Romans used them to cool their villas. The Iranians used them to preserve food in the desert before refrigerators existed. The city of Yazd, Iran, one of the hottest inhabited places on Earth, used passive underground cooling for over 3,000 years. No power grid, no freon, no monthly bill. Modern engineers rediscovered this in the 1970s during the oil crisis. They gave it a new name, Earth Air Heat Exchanger. Studies from the University of Strathclyde and research institutions in France and India confirmed it. A properly built earth tube can cool incoming air by 10 to 15 degrees Celsius. Automatically, passively, forever. This technology works. It's been proven. So why don't you know about it? The global air conditioning industry is worth over $150 billion a year. That number only goes up when summers get hotter. A system that costs $300 to build and runs for decades without power, that's not a product. That's a problem. So it didn't get marketed. It didn't get taught. It got quietly shelved in engineering archives while the world got sold on electricity-hungry boxes bolted to windows. This knowledge wasn't banned. It wasn't destroyed. It was just made invisible. And that's almost worse, because the answer to one of the biggest energy problems on the planet has been sitting in the ground literally this entire time. You already know this feeling. You've walked into a cave on a hot day. You've gone down to a basement in July. You've stepped into an underground parking garage and felt the air shift. That chill you felt? That wasn't the building. That was the earth. The ground below your feet, just 2 to 3 meters down, stays at a nearly constant temperature year-round, around 12 to 18 degrees Celsius, depending on where you live. It doesn't care about heat waves. It doesn't care about climate change. It just stays stable. And that stability is the engine of this entire system. Here's how it works. Simple version. Hot outside air enters one end of a pipe. That pipe is buried underground, where the earth temperature is cool and constant. As the hot air travels through the pipe, it loses heat to the surrounding soil. By the time it reaches the other end, inside your home, it's been cooled by 10 to 15 degrees. No compressor, no electricity, no moving parts, just thermodynamics. Heat always moves from hot to cold. Always. You're not fighting that law. You're using it. The hotter it gets outside, the harder the earth works for you. Think about that. The worse the heat wave, the better the system performs. Now, how do you actually build one? First, understand your ground temperature. In most of the world, 2 to 3 meters down, you're looking at 12 to 18 degrees Celsius. If it's 40 degrees above, that's a massive gap to exploit. Second, plan your pipe route. You need a pipe that travels underground from an outdoor intake point to an indoor exhaust point. Minimum effective length, 25 to 30 meters. Ideal, 50 or more. The pipe should slope very slightly, so condensation drains naturally. Third, choose your pipe. The most common material today, large diameter PVC or HDPE pipe, 20 to 30 centimeters in diameter. For a single room system, cost for 30 meters of pipe, roughly $100 to $250. Fourth, dig the trench. You need a trench, at least 2.5 to 3 meters deep. At that depth, seasonal temperature swings above ground barely affect the soil below. Rent a mini excavator, if possible. 1 day's rental changes this from a week of shoveling to an afternoon of work. Fifth, lay the pipe. Install a mesh cover at the outdoor intake. to keep out insects and debris. At the indoor end, install a simple vent or diffuser. A small 10-watt inline fan can dramatically increase airflow and cooling performance. 6. Backfill. Fill the trench. Compact the soil around the pipe. That earth contact is what makes this work. 7th, let it run. Open the system. Let the earth do its job. Now, here's what most people get wrong. Mistake 1, going too shallow. 1 meter underground is not enough. You need 2.5 to 3 meters, minimum, non-negotiable. Mistake 2, too short a run. 20 meters will give you tepid air. You need length for proper heat exchange. If you can't run 30 meters straight, use a coiled layout underground. Mistake 3, ignoring drainage. Condensation will form inside the pipe. If water pools, you get mold, and then you're pumping moldy air into your house. The solution, slope the pipe. Add a drain point. Use antimicrobial pipe material. Mistake 4, no filtration. The outdoor intake must be filtered. A simple mesh screen at intake and a replaceable filter at the indoor exit handles this completely. Mistake 5, expecting refrigeration. This system will cool your home. It will not freeze it. If it's 42 degrees outside, you're getting 18 to 25 degree air inside, passively, for free. Understand what it is. Passive, constant, free cooling. For a single room, one 30-meter pipe with a 10-watt fan is enough. That fan uses less power than a nightlight. For a full house, run 2 to 3 parallel pipes. In parts of rural India and Pakistan, communities have built shared earth tube systems, serving multiple homes from a single underground network. In France, passive underground cooling systems, called Putes Canadians, are legally recognized and qualify for building grants. In the United States, several off-grid communities have integrated earth tubes as their primary cooling source. The technology scales from a single room to an entire village. Is the air actually safe? Yes, with proper installation. Filter at intake. Drain the condensation. Multiple published air quality studies confirm output air from earth tube systems is equal to or better than conventional HVAC filtered air. What about radon? Valid concern in certain geological areas. Simple solution. Install a radon test kit at your indoor exit. If it's present, add a carbon filter. A solvable problem, not a deal breaker. Go back to Yazd, Iran. Stand in one of its ancient courtyard homes. Beneath those cities are kilometers of hand-carved underground channels, some still functional today, built by engineers who had no electricity, no computers, no modern physics textbooks. They understood something that took us centuries to relearn. The earth is not passive. The earth is a machine. It stores energy. It regulates temperature. It breathes. Those Persian engineers didn't fight the desert. They partnered with it. And their buildings in one of the most extreme climates on the planet stayed cool for thousands of years without a single watt of electricity. We have forgotten more than we currently know. There's something uncomfortable in realizing this, not about the technology, about ourselves. We live in an age of information, more data than any civilization in history. And yet, fundamental knowledge that could cut energy bills in half, knowledge that could keep homes cool during blackouts, knowledge that ancient farmers in Iran had figured out before Rome was built, is invisible to most people. It makes you wonder, what else we've forgotten? What else got quietly replaced by something that needed a power cord and a monthly subscription? The earth hasn't changed. The physics haven't changed. Only our relationship to them has. Maybe the most radical thing a person can do right now isn't to buy something new. Maybe it's to remember something old. You don't have to build this tomorrow, but sit with what you just learned. There's a machine under your feet, available to anyone, anywhere, in any climate, that has been working perfectly for 3,000 years. And nobody told you about it. If that changes how you see energy or technology or the systems we've been handed, share this with someone who's tired of paying for something the earth was already offering for free.